My name's John Joyce. I'm going to be speaking on enterprise web app techniques and tips. You should be forewarned up front. I don't know what I'm doing, and I'm making most of this stuff up as I go. This is the official Xojo title. This is the sexy marketing title. How Xojo let me do the impossible and generate $2 million a year in sales. I'll tell you this story. Yeah, it's honestly, it's made a ton of money for me personally and for my company. It's a very useful tool, as you all know. Let me give you some background on myself. Basically, I'm going to tell you the story or hopefully equip you with some ideas, concepts, tips, tricks, based on just my personal experience from developing the biggest web application that I've ever personally developed for my work. But about me, so I'm not really a coder. I'm not a software engineer by a long shot. I'm a hacker. I basically use Xojo to get things done as quickly and easily as possible. I like it because I can use it in so many different places to solve problems. I have a computer background, but I'm actually a marketing guy. So my career is marketing. I've been in marketing for 25 years. I've been director of marketing in 2 different companies. I ran a marketing agency, and I ran an interactive agency. So as marketing has evolved, there's been a huge kind of online component that has just grown and grown, and that for me, that balance of the technical and the creative is what I love. So on the one side, I'm doing marketing. On the other side, I'm coding stuff. That's just kind of my day-to-day. I've been using Xojo for years and years. I don't write apps that go into the App Store, but I write a lot of little utilities or things I use at the office. I've talked to many of you guys, and a lot of people use it for the same thing. You know, I'm just solving problems in little ways. I'm not making a career out of selling some awesome app on Xojo. And I love having just one tool that I can use for a variety of purposes. So when they came out with the web framework for Xojo, that was about the time when this project was coming up. Initially, I was thinking I'll build this in PHP, which is what I normally write anything for the web in. And then I thought, no, let me try to write it in Xojo. So hence out of that comes our story tale of my app. So I'm going to be sharing experiences from that for you. I hope really to kind of give you a mix of things. So like high overview kind of stuff, but also a little peek into some of the granularity, some of the details. Just from the audience standpoint, you guys, how many of you have deployed a web app on a server under your own management? Raise your hand. Okay, now keep your hand up. Up. Okay, so if that server was a Linux server, put your hand down. Okay, if that server is a Mac server, put your hand down. So you're Windows server. Yeah. Okay, sorry. I feel your pain. We can try to change that as soon as possible. No, I'm kidding. I mostly develop on the Linux side. I write on Mac, deploy on Linux. I'm not really going to cover anything platform specific, except it's all coming out of my personal experience, but the higher concepts apply across platform, right? So what am I talking about? Xojo let me do the impossible. Basically, my work came to me and said, our entire IT department says, this task is impossible, we can't do it. Do you think you can do it? Right? The marketing guy. So the task was, construct a middleware e-business app that ties together our internal ERP system, which is ancient and uses a flat file database, okay, with our distributors systems, right? So we have 6,000 distributors. They're organized in huge groups, medium-sized groups, small groups, and little onesie-twosies. They all have different systems. Some of the bigger groups were saying, we want live access into your ERP system. We want to see inventory levels at distribution centers with our pricing on all 40,000 SKUs that we carry. We want to be able to place orders, check statuses on orders, none of which our ERP system does because it's from like 1972. So we had the task was to write something that sit in the middle and allowed that functionality through various APIs and a web interface. So basically, it interfaces with SAP, Profit 21, proprietary systems. Since I first developed it, like more and more distributors just onboard to it. So it's like, okay, what is that distributor using? I'll have to write kind of an adapter layer to connect that system. Because we basically just tailor it towards each distributor. We don't make them go our way. I always go their way. So every time it's a new system, it's a new way of doing it. Our inventory information covers our 7 distribution centers in North America. It gives them real-time order placing, product search, monitoring, and reporting for the executive team. It supports North American distributors totaling over 1,000 locations, about 1,200 locations, each location having 7 to 15 people. Okay, so heavily used, a lot of people on this thing. This kind of gives you an idea of, this is over the last year, I think. Maybe it's a year and a half. We get approximately between, on the low end, 1,400 to 2,000 orders a month come through this system. For every order, there's at least 100 product inquiries, inventory checks, status things. So this thing gets hammered all day long. Thousands of transactions every day going through this system. So this is what I'm going to talk about. Why I chose the approach I chose, what the benefits of it are. The approach is using Red Hat Enterprise 7 as a server and deplorable standalone apps as the combination of multi-instances of standalone apps running on a Red Hat server, using HAproxy to balance the load. We're going to talk about how that screws up session management and how you can unscrew it. We're going to talk about how to manage the instances in a kind of sane way, which includes automatic startup and restart of failed instances. So when your Xojo app crashes, the whole system just keeps chugging along like nothing ever happened. We're going to talk about SSL termination at the load balancer, URL-based routing, which gives you the ability to run different apps on the same server, on the same port, and have different names that, or paths even, that access different apps on the same IP address, which is nice if you don't want to have 20 IP addresses or changing them all the time. So let's just get into it. So this is a standard approach, like the out-of-the-box Xojo approach. You kind of have your 2 choices. You have CGI through Apache, or you have standalone, just sitting on a server, right? And I really hate this. I mean, okay, this might be a good choice for some of you. Just for me, the idea of having to run everything through Apache just irks me personally. So I'm like, okay, I want to do standalone. It should be faster. With this project, I was extremely concerned about load, obviously, speed. The distributors give us speed constraints. So they're like, you have to be able to do this and respond within 5 seconds every time. And our ERP system can't even respond within 5 seconds. I'll tell you, it takes 50 seconds sometimes to get certain price queries out of this thing. So right from the beginning, I was like, okay, speed's going to be a problem. I don't want anything getting in the way. I'm not running it through Apache. It's just another layer. So I knew I wanted to do standalone, but then I load tested standalone apps. So I built a standalone app with almost nothing in it, literally like one line of code in the handle special URL event. I put an Apache JMeter on it and hit it just from my Mac 3,000 times in a very short amount of time, and found that when you do that, the app will spin out of control every single time. It will just go faster and faster on the CPU until it'll actually start breaking across the CPUs and consume all the CPUs on the entire server. And I could pretty much reliably produce this every single time. This is about 1.5 years ago. I don't know if they've fixed it since then, but Plus just using a web app, if you've ever just used one, if you get 5 people on a web app doing anything that requires a processor, it's all running through that one processor. I mean, if you have 20 people do that at the same time, you feel that because it's all going through one processor. So do you guys understand how the Xojo app runs everything like a single instance running on one processor, right? That's not a new concept to anybody, right? So most, like Apache will fork itself across however many processors it needs to get the job done. Your Xojo app won't. It'll just sit there and grind on one processor until it consumes it all. So that made me worried. I was like, okay, this is a good idea, but this app can't handle very much. So how do I fix that? So this is how you fix that, or this is how I fix it. There may be more than one way. Another disclaimer. Okay, the way I do things is not necessarily the best or right way. You may have a better or righter way of doing it. If you do, I'd love to hear from you in the question and answer time. This is just my trial and error approach of how to get this done. So I insert a load balancer in here. This is one server. I insert a load balancer listening on port 80 or whatever, wherever you're listening, and then run multiple instances of the same exact, I say CGI here, that's a typo. That should be Xojo standalone. So I'm running multiple instances of standalone apps. Each one runs on its own processor. So if you have a 4-processor server, which is still pretty small, right? You get 4 times the ability to handle load as just one standalone app running on that same server. If you have a 25-core server or 24-core server or more or whatever, you can get really high amount of processing power to your app. I also run Apache because one of the things I've found is if you put static content through the Xojo app, it slows the whole thing down. So I don't put any images or anything through my app. All the icons and everything come through Apache. I just link them in. I have a separate domain name on the same server that the load balancer just pulls it from Apache instead of going to the Xojo app. So now I can keep them all on the same server, run it like one unit, but when it's an image, it comes through Apache. When it's a Xojo, it comes through the app. And then there's one database. This is very simple system, but it's super scalable. That's one of the other benefits of this, since I'm already hitting a load balancer right at the top. It's very easy if I ever needed to do this, or any other way that you could imagine it being. So you could have more than one load balancer, of course, if you wanted, failover or something. You could, with any load balancer, you could run however many app server combinations you want, all tying into a DB or a cluster of databases, so it all just runs like one. The only downfall I found is if you like the ability to communicate between different sessions on the app. It's a Xojo framework feature, like I can talk to somebody else on that same app. This won't work. That won't work. You'll have to build your own way of doing that through the database or some other method, which it wouldn't really be that hard. But that's pretty much the only thing you lose. It's a little more complicated to set up, but much more scalable. I have never found, even with the amount of load we get, the need to go to an additional server. I've just run it on one server. It's very performant.
Why not run a second server for redundancy?
You could. I just haven't. Yeah, you easily could. That would be a better way to do it, probably, technically, but I've just never needed it. The server, it's been up for 1.5 years. It has never crashed. It's never gone down. The Xojo apps have never failed. They fail, but the load balancer detects it. The system restarts any failed instances. The load balancer reroutes any connections to instances that are working. So at most, the user experiences, oh, my session broke and I have to relog in, because the session will break as soon as it switches from one app to another. But you never experience the app went away. That never, ever happens. You would have to have all those fail or the load balancer fail You know, I've had the network fail and different things fail, but the server itself in this configuration has never failed.
But it does have spinning disks, or is it all SSD? The hardware always fails.
Eventually, yeah, I don't know, honestly, because this is a managed server. It's a virtual server. It's not even a real server. So this is all running on a cloud-based virtual server environment.
So this is running in like the cloud or just some other cloud? Like
Some other cloud at our data center. Okay, like you could run this on Amazon Web Services or something like that, or anywhere where you could run a cloud-based virtual server kind of setup. And it's not really, I'm not really talking about hardware failure or any of that kind of junk. I mean, yeah, those are things to take into account, but in a cloud-based system like that, none of that matters anyways, for the most part. So like, I have had the network, the NOC, the network people call me and say, the disks are bad, but they can do that in the background, like it never even has to stop, or maybe it stopped. They tell you, we're gonna shut it down for 10 minutes. And
that was an important detail, is that it's virtualized and running in a data center where they probably have a number of virtual servers and they can vMotion them from one place to the other.
exactly, yeah. But you could do that, you can do that almost anywhere. I mean, you can do that at GoDaddy, you know? So it's just a virtual server. So the benefits of the approach of having basically the multiple instances and the load balancer is this, okay? The whole system is much more stable than a single instance running on an app. It's way faster, especially with multiple people using it with the same amount of hardware. You're better utilizing the hardware that you do have. It's scalable and it handles higher loads. And like I said, the only trade-off I've found so far is the session management, which you can mostly get around. All right, so.
So is the load balancer on your server or is it being provided by the NOC?
No, it's on the server. It's all on one server. Like this is the visual of it, right? So there's one server running HAproxy, running three Xojo app instances. This is exactly how I do it. Running one Apache instance and running MariaDB. So very low hardware server requirement. We're going to talk about the load balancer slice. So I use HAproxy. I tried Nginx first. It's good. The problem with it is with the session management. To get the more advanced session management things you need with Nginx, you have to pay for the paid version, or at least you did a year ago when I built this thing. Whereas with HAproxy, it comes out of the box with a lot of tools for managing the sessions. The trade-off is HAproxy won't serve static content, so I swapped that out by running Apache. Okay, so what it gives you is it's a load balancer. It has automatic failover, so if your app goes down, it'll just start routing requests to one of the other instances. It does SSL termination very fast. It gives you very fine-grained control over your SSL parameters. So if you want to, for instance, crank up, so I won't accept SSL connections under a certain quality, you know, to prevent SSL de-escalation, which is a vulnerability that's been going around. You can set that in here. You know, don't accept key parameters lower than this size. Only accept these types of encryption, whatever you want. It also serves as a router. And it does provide some additional security. It's not a security tool, but because of the flexibility in configuring it, you can protect yourself against a few specific attacks like SYN flooding, which is hitting a bunch of connections on your app without ever saying anything to it, and slow LoRaS, which is like you open a connection to the app and you just send one character at a time like this, like every minute, and you do that 100 times, and then it takes up all your connections on your app. You can block both of those kind of attacks using HAproxy. Before I go into the granularity, because we're going to walk through a kind of a sample configuration. Does anybody have any questions on the big picture? Like why you would do it? And, yeah.
How many simultaneous connections per instance of the Xojo app can you run without logging your system?
That's a great question, and I have not measured it. So I can't say. Oh yeah, thank you. How many simultaneous connections can I run through a standalone instance? Was that more or less it? And so yeah, I have not found an answer to that. There's a lot of things that affect the performance of your standalone app besides just number of connections. So the actual architecture of the app, what it's doing, those things make a huge impact on how many people can simultaneously use it and not experience latency, you know. But at the beginning I talked about I set up an Apache JMeter and beat on it from my workstation, and I could down the app essentially with one machine, you know, beating on it. If I just set up 2 instances on a load balancer, I was unable to bring it down. So I put 3. And that's why I just arbitrarily chose 3 as the starting point, because it didn't fail when I beat on it as hard as I could at 2. So it does make a substantial difference just distributing that load a little bit. Any other questions? You first. I'll tell you about that. Yeah, just keep telling me. I'm going to do this all day long. Yeah. Are there any tricks to making the Xojo app run on in multi-instances? So yes, there are, and I'll talk about those in a minute. Same question? Okay. After this, we'll talk about systemd, which is the thing that manages the processes, and in that part, we'll cover those questions. So just some granular details about configuring HAproxy. Okay, there's basically 3 sections in a configuration of HAproxy. There's kind of a global and default section, and then there's a front end and a back end. So just to give you the explanation, global defaults is what it sounds like. Front end is parameters for the part of the HAproxy that's facing the world. Back end is parameters for the part of HAproxy that's facing your apps. So just to walk through this real quick, basically I'm turn on logging, run it as a daemon, so it runs in the background. And then here's an example. This is a real world example here. Tune SSL default Diffie-Hellman parameter 1024. So this is because this particular client was running Java 7 as their proprietary app that was connecting, and HAproxy wouldn't accept a Diffie-Hellman key lower than 2048 bits because it was not secure enough, but they were on a version of Java that didn't support it by default, and I couldn't get them to figure out how to change their key, so I just dumbed it down. But this shows you it's just an example of the level of tuning and control you have over the SSL connection. You can specify a lot. Then you go into here, globally log. This tells it we're going to be doing HTTP connections. Option HTTP log means log the connections. Don't log null, which means if something hits like a port scan hits the load balancer, it doesn't log it. It only logs if actual data comes across. Then this section here, retries option redispatch. What that means is it'll try to open a connection to the app 3 times. Okay, if it can't open a connection, it'll redispatch, which means it'll break the session rules, which we're going to talk about later, and just send it to another app. Okay, and you can define exactly how you want that to go down. This is how I use it. So it tries 3 times real quick. If it can't get through, it'll break its session rules and go to the next app, which breaks the session for the user, but gets them an app. Okay, so they re-log in and keep going. These are timeouts. So this, for instance, timeout request 5 seconds. This prevents that slow loris attack. So it says basically if a request takes longer than 5 seconds, just kill it. So you have that kind of granularity here. If I can't talk to an app for 90 seconds, timeout. If I don't finish my communication with the client for 15 seconds, timeout. So you can prevent things going on forever and just hogging up resources. Balanced least con means go to the, if this is a new connection, go to the one with the less connections. There's a variety of ways you can balance. Option forward for inserts a header into the request that goes into your app that tells the originating IP address. So if you care about where the IP address comes from, this is one of the things that you lose with a load balancer. All your requests are coming from the balancer. So in order to get the IP address back in there, you can do something as simple as that. So there's a ton of, I'm not going to cover in detail a lot of these things you could do, but you can do a lot of changes to the headers coming in before they get to your app. You can do changes to the headers going out. You can even change the content going out or coming in. So you could literally like search for Google and replace it with Apple in the text coming in and out of your app if you wanted to. That kind of level of granularity. So now we're going to look at the front end. And this is pretty much my exact front end. I changed some things and eliminated some things to make it, to protect the innocent. But basically, front end in means listen. We're going to listen, and you tell it where you want it to listen. This is how you do bind port 80 is how you do listen on port 80. Bind 443 is listen on 443, and if you want to do SSL termination, this is the hugely complicated string you have to append to your bind command. Tell it where the cert is. That's it. Now your HAproxy and everything that runs through it, including Apache or any other service you have hanging under it, is SSL encrypted, terminated at the load balancer, and your Xojo apps don't have to do any of that, which in my testing really slows down a Xojo app. I felt like they were much slower when they were doing SSL. This thing does it like lightning, so it's much faster to get it off your app. And here's some kind of examples of how you could route things, change the routing of requests. So there's probably like 4 different ways you can do routing. So this is the most common, called access control list. And this ACL just says, the format here is ACL flag condition. Okay, so we create a flag in that statement called dist sc, and the condition is that the source is that IP address. And then we can check for it right now or later and say, use a certain backend if that flag is set. Okay, so the essential routing is saying, if it comes from a certain IP address, use this backend. Now, I can define multiple backends. They could be different apps. They could be the same app. So this allows you to say, if I'm coming from a certain IP address, send them to this backend. You had a question?
Why would you want to do that? Why would you want to route based on IP address?
Well, say for instance, why would you want to route based on IP address? So say for instance, my IP address, when I go to this server, I want to see a different app that allows me to manage all the services. But I'm running them all on the same box. The load balancer can say, well, if I come from that IP address, show him the admin app. Yeah, that's with anything though, firewall or anything else like that. I should also say all of this is behind a lot of firewalling. I'm kind of like a usually security paranoid, so I lock down everything as much as I can. But there's lots of reasons why you would want to ever say, handle a certain request from an IP address a certain way. So this gives you the ability to do that. You can also route based on a path. So like if the path I'm going to contains API or handle special URL, so that allows you to actually make a separate app to handle API type requests and make a web app that handles the UI type requests, run them on the same server, and when somebody hits handle special URL, it could go to a whole other server or set of apps running on another server if I want. So this one basically says use the API access backend if I'm routing through API. So my app does API and UI type connections through the same web app. I have two backends because I just handle them slightly differently, and you'll see in a little bit. And then this is more interesting perhaps. This is route based on domain name. So if you want to have myapp1.mydomain.com, myapp2.mydomain.com, myapp3.mydomain.com, all running on the same server, all running on the same port, all standalone apps, well, this allows you to do it. And I put two different examples here. This backend is how you would do it if you're using non-encrypted connections. You just basically look at the host header and route how you want. When the connection's encrypted, it's more complicated because the headers are encrypted. So you have to look at the server name identification, which is what this is. It's just a slightly different way of writing it. Does the same thing. So that's front end. So again, review this. You've got front end is facing the client or the user, back end is facing the server. So the front end receives a request, makes some decisions about what back end am I going to use. Then you define any number of back end configurations you want to use, and it picks the one that matches. So I have 4 backends. And I'll start at the bottom here. Backend redirector. This is just the default backend, which means if for some reason I've gotten all the way through this and I haven't found a matching backend, this is what I do. I send them to the home page because something went essentially terribly wrong. You know? So that's what that is. Starting at the top here, we call this the bridge server. So things say backend bridge API and backend bridge user. So the only difference here, they could be as different as you want. You could use 2 different batches of servers to handle the API versus the UI. But the only difference here is this line and the cookie references. So there's a number of ways of connecting the sessions. So basically, if you introduce a load balancer, right, the session mechanism built into Xojo could possibly break because it uses cookies to track you that you're the same person who logged in before and show you the right screen. So, you know, Debbie doesn't get your screen and you get her screen while you're both using the app at the same time. So when you put a load balancer in between there and you say, well, I could send you to any one of 3 apps, every single time you hit anything, it breaks a session and you're back at the login screen. Okay, so in order to fix that, there's probably 4 different ways you could do that, but this is the way I chose. This is cookie injection. So what I do is I put another cookie in the request called server ID. And this is how I tag it, node 1, node 2, node 3. And then that just tells HAproxy the request comes in. Add another cookie to the header called cookie ID when I send the response of whichever server responded. And when they respond back again, if they send me that cookie, send them to the same instance. Okay, so then once you touch, even just touch the app the first time using the UI, it'll cookie you and it'll keep sending you to the same instance. So you're basically just using one instance all the time, but the guy next to you goes to the app, he gets the second instance. The other person down the hall gets the third instance. Okay, the reason why I chose this cookie is because it works whether it's one network. Some methods use the IP address. Then if you have everybody in the same office, they're all coming from the same IP address. That doesn't work. There's 2 other ways you could do it. I won't go into it, but this is a pretty common way. Okay, we could talk about if you have questions about other ways of doing it. You can use the Xojo's own cookies it can follow the cookies within Xojo itself to try to identify it. But I like this because it's unscrewable. Like if Xojo decides to change their session management or anything like this, it's completely independent. So that's what that is. And then this here just tells you where it says enter 3000 rise to fall 5. What that means is every 3 seconds I'm going to ping this app. If 5 times I can't connect to it, that app's dead. I will no longer send requests to it. If I ping it twice in a row and it's working again, that app's alive again. I'll start sending requests to it. So 15 seconds, if your app locks up for 15 seconds, right, 5 times 3, it'll quit sending requests to it. So the maximum somebody would be hung there is basically 15 seconds. What would happen is then they would get logged out because the next time they hit it or hit refresh, it's a new session to a new instance, and they get the whatever your splash screen is, but they're not dead in the water. This backend is Apache, so then I have my Apache listening on 9000, port 9000. Does everybody get all the IP address notations for the most part? I'm just assuming a lot here. If you're not into web development or whatever, I'm assuming you are, or you wouldn't be here. So listening on localhost, port 9000, anything that has that static host name, so I call it static.domain.com. The ACLs we saw earlier say use this backend. Now I can run Apache and serve my static content on the same IP address on the same port, running right next to my Xojo apps. Any questions about front end and back end? No? Okay. That's the, what the hell is he talking about look. Okay, so we're moving along to systemd now. So systemd, on most versions of Unix, is the init system. It's the system that starts all the daemons. It could also be upstart is probably the next most common. On Mac, it's launched, which is a better name. They should have called it launched. It actually works just like systemd, except uses plists instead of unit files, which we'll talk about in a minute. Windows has one too. It's like, who's a Windows guy? Like System Controller or Management or something. I can't remember the name of it. There's a startup daemon on Windows too. Works similarly, except with the registry. Yeah, starts up services. All right, so systemd in a nutshell. What does it do? Automatically starts your app instances at boot, automatically restarts any instances that are crashed. You can use a template to start multiple instances. You can start and stop and restart all instances with a single command. And you can define the environment your instances run in, which may be important if you've ever run it. If you run helper apps and you've ever run into voodoo problems with why the hell isn't this working, and some part of your helper app requires a certain environment variable to be set a certain way. I ran into this with my ODBC connection. It required a certain environment parameter. And I'm like, why the hell isn't this working? Eventually I figured it out, but this gives me the ability to set the environment I'm running in. Visually, realistically, systemd starts everything on this page, but we're going to look at how it runs our Xojo app instances because we're not going to need to mess with the rest of it. So systemd uses unit files. They're just config files. They live in the systemd directory, and they're usually named something.service. That little @ sign is important. My app @.service means this is a template, which means I can use it more than once. Normally, a service only gets used once. You start up one instance of Apache or one instance of whatever. This allows you to use the same config file for multiple instances. So it's just got a few parts to it. It's super simple. Description, when it's going to start. So this just means once the network is up, I can start these instances. If I start them before the network's up, they can't connect to ports, and who knows what's going to happen. So that's a good place to start pretty much any app that's listening. And then this section tells how to start it. So this is my path to my Xojo app. It's exactly how you would start it at a command line. If you were to start your standalone at a command line. The difference here, to answer your guys' question about starting up multiple instances on different ports, is this. So I'm using a port flag, which is a, in any Xojo console type app or web app, you can use the port flag to specify the port. And then when I say %I, that means it's a template to get the value, and I'll show you how it works. And then ampersand means it's a daemon, it just launches it in the background. It's a simple, which means it doesn't spawn any other processes or fork. Always restart it. And then you can define the group and user that you want that thing to run under, which is very nice for security purposes. So you're not starting your instances as root. You can define a user and force them to go into that user. And this just means start it by default. And here's kind of an example of how you might use it. Oh, you have a question?
Yeah, my question was about how do you keep the app running in separate cores?
How do you keep the app running in separate cores? It just automatically does it. I've found that when you start the apps up, they just automatically go to different cores. I've never had them try to start, all three come up on the same core. So there may be some way you could force it to do it. I've actually never seen it not happen, though. It's just always they come up on individual cores. So just some systemd tips and tricks. So this is how you use it with system control, systemctl, just like launchctl on the Mac. Daemon reload means reload the files after you've edited them so that they actually read, so it actually knows your changes. Then you can say systemctl start or stop my app at, and then that number goes into that port variable. So now with one command like this, I can run that app on port 10,001 or 10,002 or 10,003. And I don't have to do anything other than that. I can enable disable means flag this thing to start up, flag this thing to launch at startup. So, I just say systemctl enable my app at 10,001. When the system reboots, it'll launch an instance of your app listening on port 10,001. Of course, you have to match those ports up in your load balancer when you're trying to send requests so that the ports it's listening on are the ones you're talking to. And then a super easy trick, if you ever use the command line or command line people in the room, yes? Okay, good. So then you know about aliases. You can edit your bash RC file and just make an restart app alias that just says however many instances you want strung together with semicolons. So now you can just log in, restart app, it'll restart all your instances and go. And this is how I do build automation. So when I build my app, I'll rsync the app instances, the app itself up to the server, and then SSH remote command restart the app, and it's one click. You just hit one click, it builds it rsyncs it restarts the whole system. You could even restart HAproxy or whatever you want to string along in there. It literally takes a second. If you were using it at that moment, yeah, you would be interrupted, but it's pretty fast and pretty seamless. All right, now that your eyes are glazing over, it's over. Any questions?
Is there a way to sort of take down one instance, sort of set a flag somewhere so that that Xojo instance knows that it shouldn't have accepted more incoming requests and then stuff can get routed to it?
There is, yeah. The question is there a way just to take down one app instance if you're going to change it?
But gracefully, like have it run until it's not, no more new incoming connections, but any existing sessions will maintain more of this time.
Probably, yeah. Is there a way to take down an instance of an app gracefully? Honestly, probably not. You can communicate with sockets to HAproxy, so you could write something that tells it to stop sending connections to. You can down an app like on purpose, not just through its own detection. You can tell it to down an app, so you could down that app wait some period of time and then nobody could be using it. But no, there isn't any kind of built-in mechanism to do that gracefully, but it happens super duper fast. So, any other questions? John? Yeah, it is. Yeah, you could. Oh, is it possible to route HTTP and HTTPS requests differently to the same app? Yeah, in that front end section with the routing, you can check. There are parameters just to check, is this HTTPS or not? And then you could route it however you want it based on that. So yeah, you could route it non-HTTP connections to a whole other app if you want. So the way I normally use it is like the HTTP connections, I actually route to the stats page of Apache. So if I hit that, I get the Apache stats. So how many people are connected, how much data is going through Apache. And if I hit the same thing on HTTPS, you get the app. So yeah, any other questions? I think I have one other question that I thought you might be thinking, which is, what other things can I do to increase the performance of a web application? Because there's actually a ton of things you can do to increase the performance of a web application. Just load balancing your application is actually load balancing a crappy, slow app is not a solution. Really, it's just a piece of a solution. So what can you do? And just based on my experience, okay, and again, I'm no engineer, the things that slow Xojo apps down, are SSL. It's kind of really slow. Big list boxes, obviously. Graphics through the app. So if you can even write a graphic into a file and point at it at Apache, it would probably be faster than serving that graphic through Xojo. So if you identify some of those things, we talked about a lot of them here, like SSL and whatnot, but helper apps is another huge thing, which I'm not even talking about here, which makes a gigantic difference. So like this app is actually 7 apps. There's one app that's the UI, that's the Xojo web application, and it's the API. And then anything that does anything of any consequence is handled by a helper app, which is just a console app. So I found, like I told you, the ERP system would take 50 seconds to respond. So I put in a whole database on the local machine. Every night at 12 in the morning, there's a synchronizer that runs, pulls out like a lot of data that I regularly use, puts it in a local MariaDB, and then it runs every 15 minutes and updates like stock levels and things like that. So I never have to touch the ERP system for 90% of the things because it's just too damn slow. So I can't afford the overhead, All of that is done by other apps that run in the background. So all I got to do in my Xojo app is one MariaDB query, and it's like, boop, boop, super fast. So that's just an example. When I write an order into the ERP system, initially I did that in the app. So you hit submit order, it would attempt to open up an ODBC connection to the ERP system and put that order in the database. But that failed like 1% of the time. So essentially 100 plus orders a day, every day there's an order that gets lost, right? So that was horrible. So I wrote that to not do any of that. Instead, when you hit order, it writes a text file. And then it goes on about its business. And then there's a journaler that watches the directory of text files every 2 minutes, and it attempts to connect. And if it succeeds, it just changes the text file. I never delete them, so I can always go back and look at them. But there's a little tag on the end of the text file. So it just changes it. It succeeded. And so that way, if all my Xojo app on the front end has to be able to do is write a text file. If I can write a text file without ever crashing, I never lose an order. They all go into the journal. They all get journaled separately. I find like the console apps are way more fault tolerant, like you run things through a console app, like the ODBC connector works every time in a console app, but on a web app, it fails 1% of the time. So, not sure. Those are the kind of things that I have discovered. So you find those pain points and just say, okay, move this out, make it a separate app, run it through a shell or however you like to do it. I just put them in there, run them through a shell, and watch the output. And that's it. Any other questions? All right, thank you. Oh, one more.
How long did it take you to figure this stuff out?
It took me a year to write this. It took me a year to write it, but I work in it almost every single day because there's always something new we're doing with it. Probably every couple of months, oh, John, this other distributor wants to come on board with this system, and it's like it's like starting all over again. So like when I first wrote this, it was like a script, like it just went down like one gigantic method, like a huge method. And since then, I've had to make classes, and I've broken out all the things that happen over and again for different types of implementations in the classes so that I can reuse them, obviously. But like when I first wrote it, because of my non-engineer mentality, I'm just like, let's get this done. But then it works like crap, and the next time you go to use it, it's, you have to redo everything. So now it's all modular. So there's a piece that handles the journaling of the orders, and I don't ever have to touch those anymore. I just have to touch the front-end parsing of the requests from the client, because they all do it different.
Yeah, I wasn't actually talking about the Xojo part. I was talking about the HAproxy.
Same thing, though. Trial and error. Like before I even, he said he just meant the server infrastructure type things. How long did it take to figure out? But basically, same thing, trial and error over like several months. At first, I was just load testing everything myself because I knew that what they would do was make an announcement when this thing came online. So, hooray, we're finally done with this app, and send an email blast out to, at that time, 650 locations, saying, check it out. Yeah, and that terrified me, basically. So I'm like, okay, this thing can't buckle on day one, So I just tested it and tried it and did different things and found where it would be weak and try to figure out how to fix it by trial and error. So like before this, I never had ever used HAproxy in a setup before. I just felt like I had to. It was the only way to make it perform like I needed it to. Yeah.
How applicable would everything that you just mentioned about using HAproxy be for a console app running on Linux?
How applicable would this be for a console app running on Linux? Assuming that the console app is listening, well, yeah, it would be totally applicable. Yeah, it would be the same. Console apps are faster, but still, you're going to hit some sort of limits eventually. And especially if it's something like a console app, which is stateless, assumedly, it may not be, I guess. But if it was stateless, then it's even better because now you don't break a session. If you're just like an API that's stateless, and any of it goes down, you have zero. There's no downside. The biggest downside is the broken session problem with web applications that have a UI, and that in an API type scenario, you don't have that. So there's literally no downside. Yeah.
At this point, you mentioned that with the Xojo web app, you figured out that breaking the web application, actually delegate lots of tasks to helper apps, improves the performance. How would that be for a console app? Probably not, right?
No, it could. The question is, delegating to other helper apps improves the performance of a web app. Would it improve the performance of a console app? And the answer is yes, because the reason why it improves performance is because when you invoke that other app, it's on another core. So now your app's running on 2 cores, right? If you invoke 3 other helper apps, they're all running at the same time. They're not waiting or balancing the CPU availability of one CPU. And that would be true for console apps. So if you're running one console app and it's doing everything, you still have the one core problem. Yeah. So the main reason to ever do this is to avoid the one core problem, because that just shows up in latency under load.
Well, and you also, if you're spawning shelled out console apps to do stuff, you're getting a different CPU every time you do that. So you can run a whole lot of stuff very, very fast if you're doing that from the web app or from a single console app that then is doing that. You can spread out your load.
Correct. Right. So the comment is, if you run a web app and you're spawning console apps to do processes, or you're running a console app and you're spawning console processes as helpers, it speeds up everything because of the multi-core capability, which is true. Other questions? I think we're out of time. All right. So thank you, guys.